Ultra-processed diets have long been criticized for contributing to overeating and excessive calorie intake, but new research suggests an even more unsettling possibility. These foods may accelerate weight gain even when calorie intake is identical to that of minimally processed diets. Controlled feeding trials reveal that people consuming ultra-processed foods tend to store more fat, expend less energy, and experience altered metabolic responses compared to those eating whole or minimally processed meals, even when portion sizes and macronutrient ratios are tightly controlled. This emerging evidence challenges traditional assumptions about weight gain and raises serious questions about the biochemical manipulation built into modern food systems. One explanation lies in metabolic efficiency. Ultra-processed foods are designed to be digested rapidly, requiring very little mechanical or metabolic effort to break down. Their soft textures, refined starches, and chemically modified fats minimize the body's energy expenditure during digestion. In contrast, whole foods, rich in fiber, intact cell structures, and complex nutrient matrices, force the body to work harder, increasing energy burned through the thermic effect of food and through digestive processing. Research shows that the body may burn significantly fewer calories after an ultra-processed meal than after a whole food equivalent, meaning more energy is left available for storage as fat. This reduced thermogenesis means that two meals with the same number of calories can produce dramatically different fat storage outcomes. Another mechanism relates to hormonal signaling and appetite regulation. Ultra-processed diets tend to blunt the release of satiety hormones such as GLP-1 and PYY while increasing levels of ghrelin, the hormone that stimulates hunger, even after eating. These hormonal disruptions encourage faster return of hunger and lead to reduced metabolic flexibility, nudging the body toward fat preservation rather than fat burning. The metabolic machinery designed to regulate energy use becomes confused, shifting toward efficiency rather than expenditure. The body behaves as if it must protect resources, conserving fat instead of releasing it, an effect similar to what occurs under chronic stress or sleep deprivation. Digestive differences also play a critical role. Whole foods move more slowly through the digestive system, supporting stable blood glucose, steady insulin responses, and consistent energy availability. Ultra-processed foods, however, are absorbed rapidly, causing steep glucose spikes followed by sharp crashes that push the body into fat storage mode. Rapid digestion floods the bloodstream with nutrients too quickly for cells to process efficiently, leading to insulin surges that encourage lipogenesis, the conversion of excess nutrients into stored fat. This cycle can occur even when total calorie intake appears perfectly balanced on paper. A striking example comes from metabolic ward studies in which participants eating ultra-processed diets consumed the same calories as those eating whole foods, yet gained more body fat and lost less muscle mass. These findings imply that the human body responds differently to engineered foods at every stage, from digestion to hormonal communication to cellular metabolism. Ultra-processed foods appear to rewire metabolic priorities in favor of conservation and storage, making weight gain almost unavoidable regardless of calorie counting. For individuals trying to manage weight, this means the problem may not be overeating or lack of discipline, but a biological system manipulated by food design. Another emerging concern is chronic inflammation triggered by additives such as emulsifiers, stabilizers, and artificial sweeteners. Inflammation interferes with normal metabolic signaling, reducing the body's ability to oxidize fat and increasing insulin resistance. When inflammation is persistent, cells become less responsive to metabolic control, forcing the body to store more fat, even when energy intake is modest. Combined with gut microbiome disruption, another consequence of UPF-heavy diets, this creates a metabolic environment optimized for weight gain rather than maintenance or fat loss. These insights sharply contradict the long-standing belief that a calorie is just a calorie. In reality, the physical structure, processing level, and chemical composition of food profoundly influence how calories are used, stored, or burned. Ultra-processed foods remove nearly every natural obstacle the body relies on to regulate appetite and energy balance, stripping away fiber, texture, nutrient density, and metabolic resistance. What remains is a product engineered for maximum consumption and minimum metabolic effort, a combination that silently drives weight gain even when people believe they are eating responsibly. The warning from scientists is direct. Relying solely on calorie labels ignores the deeper biological consequences of food design. Ultra-processed diets function like a metabolic trap, pushing the body toward fat accumulation and energy instability even under controlled intake. For millions struggling with unexplained weight gain, frustration and self-blame may be misplaced. The problem may lie not within personal choice, but in a food system built around products that undermine the fundamental mechanics of metabolism. If society continues to normalize these foods as harmless convenience, the result may be generations living inside bodies that resist balance, fight against stability, and store fat at every opportunity. The cost of convenience may not just be overeating, it may be a fundamental rewriting of metabolic function that no amount of willpower can undo.